Dear students, good morning. Today we will continue the Tondy formulas, that is the shortcut methods. Previously, I taught the 6 formulas which are very useful to solve the problems in the objective exams. Now, I am going to solve the 7th one. You see, as we know, 1 plus x power n, the binomial expansion. It is nc0 plus nc1 x plus nc2 x square plus nc3 x cube and so on up to last ncn x power n. We write this formula. It is in the binomial theorem. nc0, nc1, nc2, nc3 up to ncn. And here is x power 0, x power 1, x square, x cube, x power n. Yeah, okay. We know it. Put x is equal to 1. Then it is 1 plus 1 power n. It is nc0. I am writing one notation. Always writing nc0, nc1, nc2, ncn. Is simply write c0. It is c1. c1 means nc1. c0 means nc0. x is 1. 1 into nc1 is nc1. nc1 is simply c1. Here also nc2 into 1 square. nc2. nc2 is c2. Okay na? It is c3. And so on up to it is cn. This is the sum of binomial coefficients. They are called as sum of binomial coefficients. Here it is 1 plus 1, 2 power n. Therefore, we conclude that the sum of binomial coefficients, that is C0, C1, C2, C3 and so on up to last, Cn is equal to, this is 2 power n, 2 power n. Here, you leave this proof, it is not needed. Only this is the formula, a 20 formula. You see, here the concept is we are selecting 0 things from n things. We are selecting 1 thing from n different things. We are selecting 2 things from n things. Just like those sum is 2 power n. Where we use this concept, I will tell it. You see, one more thing. Again, if you substitute x is equal to minus 1, then you see, first I will write the RHS. It is C0. Here x is equal to minus 1. So minus nc1, that is C1. It is minus 1 square is 1. 1 into nc2 is C2 plus C2. Again it is C3. Next C4. And it's going on. The last one is, we don't know, the nth term is minus 1 power n Cn. Here minus 1 power n. N is even, we get a plus. If n is odd, we get a minus. Okay now? Here in the LHS, 1 minus 1, 0. 0 power n is 0. Okay now? Here, I will write it as C0 plus C2 plus C4, C6 and so on, all positive terms. And negatives goes to that side, it is C1 plus C3 plus Cy and going on. Okay now? Like this. Is equal. Okay now? You see, it is 0. I am keeping LHS, the positive terms, and the negatives to that side is go. In the RHS, it will become as a positive. Yeah. C0, C2, C4, C6 is equal to C1, C3, C5 and going on. Let we assume this is A. This part is just like we assume this is A. Okay now? And it is B. So A is the sum of even coefficients. B is the sum of odd coefficients, binary coefficients. So A is equal to B. Now we see, I will write here. I consider A plus B by 2. We know that B is equal to A. So it is A plus A by 2. It is 2A by 2. It is A. Okay, na? Therefore, A plus B by 2 is nothing but A. We prove by using that one. And that A is nothing but again. Therefore, A is equal to B is equal to A plus B by 2. What is A? A is the sum of even coefficient C0, C2, C4, just like. And B is odd coefficient. It is C1, C3 and dash by 2. So it is in order C0 plus C1, C2 plus C3 and to last Cn. It is by 2. We know that this is the sum of all coefficients, binary coefficients, is 2 power n by 2 is there. So it is 2 power n minus 1. The result is in LHS A. What is A? C0 plus C2 plus C4 sum of even coefficients is equal to sum of odd coefficients. Okay, na? And it is nothing but 2 power n minus 1. It is some more result. The sum of all binary coefficients is 2 power n. The sum of even or the sum of odd is again equal to 2 power n minus 1. But this proof is not needed. Only these two are the important concepts. Now, where it is used, we will see. You see, out of n different things, number of selections, the number of selections of selecting one or more. Okay, na? There are n different things. N different things are there. We are selecting one thing or otherwise more, or means 2 things or 3 things or 4 things, up to n things also. Then what is the number of selections? This is the question. You see, here out of n things, the first is selecting 1. That is NC1, we know it. R means plus, and means into. We know it in the very basic concept. Out of n different things, selection of one thing is NC1. R means plus. NC2 means selection of 2 things out of n. Or NC3 means selection of 3 things out of n different things. And it's going on up to last n. We may select n things from n different things. Okay, na? The answer for this question is NC1 plus NC2 plus NC3 and going on up to last NCn. That means out of n different things, we may select 1 or otherwise 2, otherwise 3, 4, 5 and going on up to n things. We know by using the first property. That is 2 power n means C1. But there you see in the formula C0 plus C1 plus C2 up to Cn is there. It is 2 power n. But we have this one only, C1 plus C2 plus dash dash Cn. It is 2 power n minus C0. C0 means NC0, always 1. NC0, 10C0, 10C0, 11C0, 20C0, anything C0 is always 1. So its answer is 2 power n minus 1. Okay, na? That is the concept. Okay. One more example. I want to solve. Example. You see, in how many ways a student can fail in his PU exam. Just I am taking an example. Please try to understand. In how many ways a student can fail his exam, PU exam? You see, I can explain there. Observe me. The PU student having the subjects mathematics, physics, chemistry, bio, English and Kannada. Okay, now there are 6 different subjects. Of course, language also I am taking a subject. There are 6 different subjects are there. If the student wants to pass his exam, PU exam, he has to pass all the exams. Okay, now the only one case is there. If he passes all the 6 papers, he can pass the PU exam. But the question is, in how many ways that he can fail in his exam. You see, suppose he fails in all 6 exams, yes, he failed. Passing 1 exam and failing in 5 exams, then also he fails. Is it done? Or at least in the 4 exams he failed means totally he fails. Is it not? Otherwise all exams are passed. Yes, he can pass the exam. Even in 5 subjects, different subjects, he may pass. But he fails in 1 exam, say maths or physics or chemistry or any 1 exam, then also he can fail. So in how many ways are there? That's important type question. Concept is important. You see, he may select out of 6 different things, one thing, one subject, either maths or physics or chemistry, bio or English or Kannada, to select out of 6, select to get fail. Or he may select 2 out of the 6 to get fail. Or 3 or 4 or 5 or 6. In case of 1 subject is failed, he get failed. 2 subjects, 3 subjects, 4 subjects, 5 subjects and 6 subjects. Also, there is a chance to fail. Okay, now, this is nothing but like that formula, it is 2 power 6 minus 1. Will you agree? The same procedure. N is 6. Okay, now. So, this is 64 minus 1. So, there are 63 chances are there a person can fail in his PU exam. Only 1 chance is there to get pass. You see in this example, in how many ways where we have to face 63 types of ways are there. We may fail in the exam, but only 1 way, that is we have to pass in all the exams. Okay, now you take the concept is important. Okay, pass. Yeah. Eighth one. You see, the number of zeros, in the expansion of 100 factorials. Okay, now you see, this type of question is asked. The number of zeros in the expansion of 100 factorials. 100 factorials means it is 100 into 99 into 98 into 97 into and so on up to 3 into 2 into 1. It is a very big, very large number, having a digits nearly more than 120, 125 digits. It's a very big, very large number. Very large number. In that large number, how many zeros are there? For example, the question is, suppose 576 3 zeros means it is 5,76,000. So there are 6 zeros. Suppose 50 lakhs 60 76,000 means not 4 zeros, only the last digits. If they are ending with zeros, that is the number of zeros. Okay, now that is the meaning, not 4 zeros. Like this, in this example, in this expansion, what is the number of zeros? How many zeros are ended with this biggest number? You see, suppose the number 100 factorials, observe me first, 100 factorials. It is a very big, very large number. That number can be simplified in its prime factors. That is 2 power p, 3 power q, 5 power r, 7 power s, and so on. Maybe 11 and 13, 17, like that, maybe. A very large number. It is not possible and not needed also. You see, only the 2 and 5 will give the 10, means 1 0. Here, this means it is 2 into 2 into 2 into p times. Okay, now? Again, it is 3 power q means 3 into 3 into 3 into dash dash q times. Okay, now? And 5 into 5 into 5 into dash dash r times product. And it is going on. It's not needed. Every 2 and 5 gives 10. Again, the 2 and next 5 is 10. Again, 2 and into 5 is the next 10. Like that, it is going on increasing. The set 2 and 5 gives 1 0. 2 and 1 more 5 gives another 0. For example, 2 cube into 5 power 4 is there. It is 2 into 2 into 2. It is 5 into 5 into 5 into 5 into 5. That is 1, 2 into 5, 10. 2 into 5, 10. 2 into 5, 10. And there remain 5 only. But here we get 1000. So 3 zeros, like that. How can you say this P, this is P and this is R there. So if P is less than R, number of zeros, try to understand, number of zeros is equal to P. Suppose P is greater than R, that means R is less than P. Then number of zeros is equal to R, which is out of these two is lesser, that is the number of zeros. Okay, na? In this concept, you see, I am explaining the total concept. But it is not needed. Very simply by using Tondy method I can solve.